present research on the future of water purifier technology. The research is going on in this way. The contents, one is introduction, and the secondly experimental, thirdly analytical research, and finally we will make some conclusion on this. Let's make some introduction like this. Water purifier technology is getting smarter day by day. Water purifier lasting from small households using existing cooling technology to large businesses. In addition, competition among water purifier manufacturers is intensifying from large companies to small and medium-sized enterprises. They are targeting consumers with various functions and sophisticated design nowadays. However, technically, the core technology of water purifier are cooling technology, and secondly, hot water and the water purification technology. And the core all water purification is the future. In terms of function, cooling technology is related to cooler technology, and the hot water is an esteemed technology that applies heat, is not an innovative technology. Water purifier is an environmental technology that is directly related to the water quality, and it is a field that requires careful and continuous technology development because it is harmful to human body if applied incorrectly. Moreover, as the Earth suffers from the serious problems due to the global warming, and water is sometimes life-threatening factor without drinking water even for a day. Fortunately, Korea has good water quality compared to other countries, but Vietnam, China, and the Middle East, Africa, Indonesia, and other places on the earth have poor water quality or level water. According to tech science research, our global market research firm is 2018. The Vietnamese water purifier market values in 2017 was approximately $160 million. In addition, the Vietnamese water purifier market has grown at a compound annual growth rate of more than 12% since 2017, and is expected to exceed $221 million by 2023. These factors can be attributed to increased industrialization, improved living standards, and consumers' concerns about the disease related to water pollution. In particular, there is a trend of increasing consumer awareness due to environmental pollution and an aging water pipe management system in Vietnam. In 2019, Vietnam import water purifiers worth about $124.48 million. Okay. And the major importer of water purifiers was Korea, which is 83.84%. China is about 32.84%, and Japan 8.41%. Domestic water purifier companies are increasing their sales by entering Southeast Asia, comparing 2012 and 2018. Huawei companies grows at an average annual rate of 40%. As for the Chengdu homes increased by 36%, and Malaysia's market share of Korean water purifier products in 2018 is about 50%. Currently, the penetration rate of water purifiers in Malaysia is less than 30%. This is significantly lower than the penetration rate of water purifiers in Korea. This is about 60%. As such, there is some room for entry into water purifier market in Malaysia. Huawei companies enter the Malaysia market in 2007 years. Chengdu homes in 2015, and FoCoS and FoCoS.IDIC is in 2018. On the other hand, the domestic water purifier market is showing low growth rate of 2.2%, which is thought to be because of a significant number of water purifier manufacturers have already been established, and the number of bottled water manufacturers, including Sandasu, has increased. Marketing consumer less likely to feel or need to install a water purifier. The domestic water purifier market is growing at about 2% per year, which is a relatively low growth rate. Therefore, in order to open the domestic market and extend water purifier market, it is important not only to develop its own technology for water purifier equipped with artificial intelligence, but it also to open up new markets overseas, which is not receive the benefit of water purifiers. This project aims to develop the technology that allows consumers to easily self-diagnose or manage water purifier by recognizing and analyzing the current water purifier focused on water purifier management system. Let's go to the experiment. For the experiment, the current water purifier management was performed by specific management personnel, but due to low professionalism, reliability of water purifier management was inferior, and the filter was replaced unnecessarily, or only partial cleaning was performed. In order to efficiently manage such water purifiers or modular water purifier was that allows consumers to manage themselves have been developed. The replacement parts such as filter are delivered in a timely manner so that the consumer can manage them directly. In order to allow the consumer to directly manage the water purifier, it is necessary to develop the modular water purifier so that the existing water purifier structure system can be systematized and can be combined by functions such as water filtration, hot water, and cold water. This water purifier system by function is as follows. Let's look at some overall view of the system. When the hot water is into the purifier, the purifier water module, and then there are separate three different modules include. One is a hot water module, secondly cold water module, stabilized module, and there is some connection by control module, and finally you can ask consumer to manage self-management. This figure shows some kind of result which we systemize the purifier. This is a water purification module test. It's a water pressure of 1 kilometer force per centimeter of tap water was supplied to the water purifier, passed through the filter, and then the time requires to drain 150 cubic centimeter, and 1,000 cubic centimeter purified water was measured. It took 4 seconds to dispense purified water, and it took 30, 26, and 27 seconds for each cycle to dispense 1,000 cubic centimeter purified water. Considering the test error, the average discharge flow rate is estimated to be about 38 cubic centimeter per second. This is summarized for what I mentioned just now. Secondly, this is showing the hot water cases. Hot water, this figure shows the power consumption of the module test for heating tap water at 70 degrees to 85 degrees was measured. There are discharge in full power consumption according to the applied water output and the consumption time. The higher pressure power consumption, the higher the applied energy. So time was shortened even if the amount of hot water was the same. If the amount of hot water increased, the energy consumption increased, so the time requires become larger. This is summarized what I mentioned just now. Finally, we did some kind of experiment like this one. So this is kind of so-called motor and control interlocking test. For the cooler motor interlocking test, set the temperature of cold water was set to 7 degrees, and the operating temperature of cooler system was set at 9 degrees. The water temperature was set 12 degrees, and the water output per minute was set at 400 cubic centimeter. And this table shows the water output temperature change according to the water outlet volume, while the compressor temperature is fixed 4 degrees. Water output temperature was constant at 7 degrees until water output of 200 cubic centimeter. But the temperature goes slightly to 8 degrees until the water output of 400 cubic centimeter. And in addition, it is confirmed that when the amount of water output was increased to 1,000 cubic centimeter, the temperature of water output started to increase. Also, in case of a continuous water discharge, for example, when the 2,000 cubic centimeter water was discharged, the cooler operating time is increased rapidly to about 15 minutes. And in case of 3,000 cubic centimeter water cases, the cooler operation time is 150 minutes. In addition, the temperature when the cooler is stuck inside the cooler system, and the change in temperature inside the cooling system after the cooler is stuck were measured. As a result of even though cooler was stopped, was confirmed the internal temperature of the cooler system dropped by 4 to 5 degrees. This showed some kind of results what I mentioned just now. Let's make some conclusion from this. Okay. In the current rental management system of water purifier management confirmed from the filter replacement and the technology to extend non-face-to-face management, the system is increasing in a situation where consumers are requesting non-face-to-face management system to ensure product or personal life. Therefore, water purifier technology is advancing in this non-face-to-face direction. Through this project, the current water purifier technology was inspected and the technology was prepared to systemize water purifier so that consumer can easily access it. In addition, if an efficient service management system based on the app is applied, is expected the total rental costs can be reduced by more than 40% by allowing consumer to easily replace or self clean filters, etc.